Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on September 1st, 2025, about 3 days ago. The standout result is a simple switch to importance weighted retrieval that consistently beats nearest neighbor retrieval, with gains like 5.8% over Sailor on Libero and roughly 30% average improvement on Bridge real-world tasks. The paper is titled, Data Retrieval with Importance Weights for Few-Shot Imitation Learning. And as we'll see later, the implications for training small demonstration policies are quite significant. In short, the method reframes retrieval probabilistically, using Gaussian kernel density estimates to compute importance weights that reduce variance and bias. On X, a co-author announces importance weighted retrieval as a simple drop-in fix for few-shot imitation learning, highlights inspiration from importance sampling, and notes a co-RL oral. Engagement looks moderate with 93 likes. Alright, the previous segment highlighted the probabilistic motivation. Figure 1 presents the pipeline. First, a latent space encodes state and action pairs, which means raw observations get mapped to compact vectors that preserve task structure. The middle panel computes importance weights as target density over prior density, so samples that match target demonstrations but are rare in the prior rank higher. The right panel then co-trains a policy on target data plus the top-weighted prior samples, which yields better generalization with fewer demonstrations. So, Figure 2 contrasts nearest neighbor retrieval with importance weighted retrieval. The top panel shows that L2 distance picks the prior point near Z, ignoring how many target points lie nearby overall. The lower panel adds a smooth target density curve, which raises the weight of X because many target points cluster there, so X gets retrieved. This illustrates why smoothing with kernel density estimates reduces variance and better matches the target distribution. So the previous figure clarified why smoothing helps. Table 1 presents success rates across simulated Libero and RoboMimic square tasks and real bridge sync tasks, and the table shows consistent gains for importance weighted retrieval. IWR tops square at 84% and improves mug pudding to 45%, which beats the nearest neighbor baselines. On real tasks, IWR reaches 9 of 20 on corn and 14 of 20 on carrot, and for eggplant, it hits 20 of 20 partial and 11 of 20 full successes. Alright, the previous figure reported headline gains. Table 2 compares adding importance weighted retrieval on top of two retrieval embeddings, skill retrieval and flow retrieval, across simulated and real tasks. The table shows consistent boosts for skill retrieval on square and mug pudding, and stronger real improvements for flow retrieval, which suggests the weighting helps when flow features are noisy. Table 3 then tests why it works. Removing the prior normalization or shrinking the kernel bandwidth lowers success, so the probability ratio and smooth densities matter. Okay, the previous table tested bandwidth and normalization. Table 4 reports how retrieval thresholds affect performance on square, which matters because pulling too much prior data can mix in off-task trajectories. The table shows success peaks at 30 to 50% retrieved, with 71, 84, and 88% respectively. At 60%, success drops sharply to 54%, so aggressive retrieval hurts. The takeaway is that a moderate threshold preserves relevance while still boosting data diversity. Wrapping up, two takeaways stand out. Importance weighted retrieval reframes selection as a probability ratio, which cuts variance and bias compared with nearest neighbor scores, and this simple swap consistently lifts success on simulation and real robots. The broader implication is practical few-shot deployment with less hand-tuning. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.